Okay. Okay, so that will be the PVT section. And then we go to input, tank data. Okay. So the name of the reservoir is Eng-Man, Eng-Man reservoir. The temperature, assuming isothermal condition. Okay. Initial reservoir pressure, 2,210 pSIA, porosity 13%, Courant water saturation 0.34, water compressibility, we use correlation, oil lag 0, okay, there is no oil lag initially in the reservoir, and the original gas in place, this value, okay, 30 something BCF, but of course you need to get good matching in order to be able to use this as your OGIP, original gas in place. And this is the start of production. Water influx. Okay, you need also to do matching to get the correct or the representative geometry of your aquifer. Okay, and by the way, we will skip the matching step for water influx for determining aquifer property because as you can see, the model is ready. So I'm just going to show you only the already populated data. Okay, and hopefully in the future we can also construct this kind of case starting from scratch. Rock compressibility, use correlation. Okay, but you can also use user specified if you already perform geomechanical laboratory experiment to know that the rock compressibility is actually changing with pressure, and it will influence the porosity and permeability over time. You can also input that, but in this case, I will use correlation. Rock compaction, like this, reversible, and then relative permeability. Okay, so if you have the relative permeability data, you input here. In this case, I will use Cori function to generate the curve, and then the endpoints are like this. The relative permeability for water, oil, and gas at the endpoint, and then the exponent is like this. Production history by tank. So I have the production history. I input into the tank. So as you can see, I provide history of the date, the pressure, cumulative oil produced or cumulative condensate produced, gas, and also water. Plot. Okay, so this is the plot for pressure. Okay, and then for the cumulative gas production. You can also plot cumulative oil production. Okay, cumulative gas production, like this, cumulative water production. Okay, so I will close, click done. All right, so after inputting all the data, of course, we go to the next step, which is history matching, analytical method. Okay, so as you can see, I have achieved a very good match in this case. So I can use this gas in place to be used in later in the simulation or in the CO2 injection forecasting step. Check regression. You see, I regress the gas in place and also the aquifer constant to get the good match. Okay, initial oil lag, I'm quite confident it's 0, so I will not use it for regression. Outer inner radius, I'm quite confident with 3. And then this one, time constant, also good. So I will regress only for the gas in place and the aquifer constant. Okay, so I'm quite satisfied with this quality of matching. Finish. We can also check the graphical method. Okay.